Dear students, I start with lecture 3 of Math 305. In the previous lecture, we have discussed about the Pascal triangle. That we start with 1, 1. Then the sum of 1, 1 is 2. 1 is carried forward. Sum of these 2 is 3. Sum of these 2 is 3. 1 is back. Or you may consider 0 at all other ends. So, sum of both is 1. Likewise, you can understand. This is 1. Sum of both is 4. Sum of both is 6. 4. 1 is carried forward. And likewise others. The meaning of this is that if you take a plus b raised to 1, means it is 1 time a, 1 time b. I use different color chalk. Okay. So this is 1, 1. From where we started. Then 1, 2, 1. A plus b square, that is a square. 2ab b square, means it is 1 time b square. 2 and 1 time b square. Then a plus b cube, that is a cube 3. You know this. But what is meaning there? 1, 3, 3, 1. 1, 3, 3, 1. Okay. Then take 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And similarly for others. So just pay attention on the Pascal triangle and this expansion. This is binomial expansion. Now I start with binomial expansion. Binomial expansion. In Gujarati, we used to say Dvipadi Prameya. Binomial expansion theorem. Dvipadi Prameya. So this is equal to sigma NCK K equal to 0 to 10. Actually, we want to progress, and we have proof for that. So first, a plus b raised to 1 is sigma 1 ck k is running from 0 to 1, means we put n equal to 1 here. Therefore, this is equal to 130. First we put value of k0. K e raised to 0, 1c1, e raised to 0, e raised to 1. So this is equal to 1c0 is 1, 1c1 is 1, and therefore this is only a, and the second term is only b, and therefore a plus b raised to 1 is a plus b, and therefore this result is true for n equal to 1. Next we suppose this result is true for f, and therefore a plus b raised to m k equal to 0 to m mck say this is equation number 1. Now we want to prove this result is true for k equal to n plus 1. Okay, means n plus 1, we have to prove this result is true, and for that, therefore a plus b raised to m plus 1 is a plus b raised to n. This is equal to a into m, a plus b raised to n, we multiply it. Say this is equation number 2. Now we find simplification for this, and therefore a into a plus b raised to n into sigma mck where k is running from 0 to m, means we put this value here. But if I take this a inside, it is plus 1, and we can cancel out these. Okay, it we have the same thing. Now if we put k equal to 0, a raised to n plus 1 a I say this is equation number 3. This is expansion of this term. Now we want to find the expansion of this term. And therefore n is equal to V sigma mcj v raised to j. J is running from 0 to f. Now if we keep this b inside, then it will be j plus 1. I think you understand. Now if I put j equal to m plus 1, j equal to m, this is equal to sigma j equal to 0 to m minus 1 mcj e raised to m minus j b raised to j plus 1 plus b raised to m plus 1. Means we put value of j equal to m in this equation. And therefore, I say this is equation number 4. Now, adding 3 and 4, here I can put say j plus 1 equal to say k. Therefore, j equal to 0 implies k equal to 1. Consider only this part. And if we put j equal to m minus 1, the value of k is m. We put this value in this equation. This is sigma a equal to 1 to m mck minus 1 I said this is equation 4 days, and I said this is equation 4, and then we adding 3 and 4. Therefore, plus 4 implies a plus b raised to m plus 1 equal to, this is 3 a raised to m plus 1 plus sigma mck k running from 1 to m a raised to m plus 1 minus k b raised to k. This is equation 3 and that is equation 4 plus sigma k running from 1 to n mck minus 1 this is k m plus 1 minus k b raised to k plus b raised to m plus 1. Just see there, the first is equation 3 and the second bracket is equation 4. Now if we combine both of them, this is equal to a raised to m plus 1 plus sigma k running from 1 to m mck plus mck minus 1 e raised to m plus 1 minus k d raised to k plus b raised to n plus 1. Now see there, we have proved the Pascal rule. The value of this is m plus 1 k, that is from 8 Pascal rule. And therefore, if we combine all in all, sigma therefore this formula is true for k n plus 1, and by induction we say that it is true for all n in n, and therefore we say that this is binomial theorem is true for all n in n. Okay, dear students, now we start with division algorithm. Actually, there is nothing in this algorithm. In Gujarati, we say ભાગાકારનો નિયમ. But in this paper of elementary number theory, this is a base of so many topics which we will learn in this paper. So it is very important aspect. So try to understand that. See here, division algorithm. Given two integers a and b, b is positive. There exist unique integers q and r which satisfies a equal to bq plus r. And obviously, as this is remainder, the value of r is in between 0 and less than b. The integers q and r are called quotient and remainder. Whenever we divide b by a, we divide a by b. So we want to prove this. So try to understand this statement of this theorem. Actually, this is algorithm, but as per me, it is theorem. I will continue this lecture, means I stop this lecture here and continue in the next lecture. So try to understand this idea of division algorithm, which you have learned in the previous years, means in the beginning of the mathematics schooling time. This is different. I stop here for this lecture. Thank you very much.